Here we are given three polynomials and asked to use the zeros theorem to determine the number of real and imaginary zeros of each. The zeros theorem says that every nth degree polynomial equation has exactly n solutions in the set of complex numbers. So let's look at the first equation, x to the fourth minus 2x cubed minus 11x squared plus 12x equals 0. I've entered the related polynomial into the polynomial function into the y equals screen, and I'm going to go to Zoom Standard. And we see a polynomial graph that crosses the x-axis 4 times. And so we know that we have 4 real zeros, all with multiplicity 1, as a matter of fact. So since we have 4 real zeros, we will have 0 imaginary zeros because the number has to add up to be 4. Notice that in the second case, the initial polynomial has had 8 subtracted from it. And so for the graph will be moved down 8 units. So when we look at it, let's go back to the y equals screen, and I will subtract 8 from the end of this function and regraph. The polynomial has been moved down far enough so that what were the middle two zeros are no longer zeros. And so this time there are 2 real zeros because only 2 x-intercepts. And therefore the other 2 zeros have to be imaginary. In the third case, 43 has been added to the original polynomial. And so going back to the graph, I'll replace the minus 8 with a plus 43. Now try to picture what might happen. This has moved the graph up a relatively large distance, 43 units. Ooh, we're only seeing a little piece of the graph. Let me increase the Y max in the window screen. Let's take it up to 50. And what we notice is that the function does not cross the x-axis at all. Therefore, in this case, we have 0 real solutions and 4 imaginary. Just want to make one comment. If we had had a graph where the polynomial had touched the x-axis in that middle area, so we would have 3 x-intercepts, notice that this middle 0 would have multiplicity 2. And so in terms of the zeros theorem, we would say that this case had 4 reals and 0 imaginary, just like the initial one. Because in the zeros theorem, we do double count functions with multiple, or zeros with multiple multiplicity.